Okay, I'm going to be working here on the homework for 12.5. So the first question asks whether or not this is a proper rational expression or not. So all we're doing here to check if it's proper is determining whether or not the degree of the numerator, which here is 2, whether or not that is smaller than this degree of the denominator here, which is 3. So in this case, since 2 is less than 3, the answer would be true. Now, had they been equal or had the numerator been bigger than the denominator, then we would say it's false. Okay, let's move on. Oh, can I check this? Okay, next question. All right, so they want us to factor this. Let's see, do I really want to go through factoring? I'm not going to go through factoring. Factoring, well, yeah, you know very well. Okay, so we want to factor that. We have 2x to the 4th plus 12x cubed plus 18x squared. So to factor this, first I realized there's a 2 in everything that I can factor out, and then also an x squared. So I can pull that out, and then I'd be left with x squared here plus 6x. And then I pulled out 2, so 9 there. And then this, excuse me, hold on. So this is a trinomial here. This would factor to be, let's see, x plus 3 times x plus 3 again. So this becomes 2x squared times x plus 3 squared. So let's see how easy that's going to be to type in here. So 2x squared times x plus 3 squared. Okay. Next one. So is this proper, improper? This is proper because that 2 is smaller than 5, so it is proper. Okay, this one is improper. Okay, so the numerator, the degree is 3, here is 2. So because this is bigger than this, we actually have to rewrite it. We have to do long division. So I'm going to do long division. 7x cubed. Now, very important, I'm going to put a 0x squared since there is no x squared term in the numerator. Then 8x minus 9. On the outside, I put x squared minus 9. So again, putting a 0x squared here is important because if we have any x squareds that appear when we do our work, we need a column to put the x squared. So I have to put that there. Now, in order to turn x squared into 7x cubed, I need to multiply by 7x. And then when I do that and multiply that 7x times this, I get 7x cubed. And then 7x times this, I get negative 63x. So I'll put that here. Now we come through and subtract. So it changes that to a minus, changes that to a plus, and then we add down. So we get 0 here, we get 0 here. Here we're going to get 71x. And then when we bring the minus 9 down, we have minus 9. So now we kind of play the same game. We see, can we turn x squared into 71x? No, because the power x squared is bigger than x. So that's our remainder. So we put plus 71x minus 9 over our divisor x squared minus 9. So let's see if we can't type that in. This is going to be 7x and then plus the fraction 71x minus 9 over x squared minus 9. All right. Okay, moving on. Next question. Tell whether it's proper or improper. So the degree of the numerator here, if we distributed that through, let's go ahead and do it. It'd be x squared minus 3x. And the degree of the denominator, if we FOIL this out, we would get x squared, let's see, plus 3x minus 40. So I went ahead and did that kind of mentally, but I trust that you could do that. FOIL the bottom out. You can see these have the same degree. And since they have the same, it's improper. But now that means I need to do long division. So I need to do x squared minus 3x here, and then x squared plus 3x minus 40 out here. Now to turn x squared into x squared, I have to multiply by 1. So I'm basically going to hit each of these with a 1, which is just going to spit out exactly what's there. And then I subtract. So when I subtract, this becomes minus, that becomes plus. And then I add straight down. When I add down, these go away. These actually turn into a negative 6x. And then this turns into plus 40. And that's my remainder because x squared cannot be turned into negative 6x. So we'll put plus negative 6x plus 40 over my divisor, x squared plus 3x minus 40. I realize I'm moving kind of fast here, but just trying to make sure you understand the basic idea of how to do these. Minus 6x plus 40 over x squared plus 3x minus 40. Okay, let's see about that. Okay, doing good, doing good. Okay, write the partial fraction decomposition. So finally, we're getting into partial fraction decomposition. So here we got 2 over x times x minus 2. So we know that the degree of the numerator is 0, the degree of the denominator is 2. So we can go ahead and factor the denominator, but it's already factored. So we're ready for the next step. Each of these are linear. So I'm just going to put a number a over x and then plus some other number b over x minus 2. And now I'll multiply both sides by the denominator, the common denominator. And all we'll get on the left is 2. On the right, when we pass this here, the x's cancel. I still have an a and an x minus 2. And when I go here to here, the x minus 2's cancel, so I still have a b and an x. And here we can use a shortcut method here. Let me figure out what a is. So to get a, I'm going to kill this one off by letting x be 0. If x is 0, the whole equation turns into 2 equals a times 0 minus 2. So 2 equals negative 2a, and divide through by negative 2, you get negative 1 equals a. Okay, now to figure out what b is, I'm going to let x be 2, and that will kill off this piece. So if I let x be 2, I get the left side's 2 still. I get 0 there, because when I plug 2 in here, it's going to kill all that out. So I'll just get b times 2. Divide both sides by 2, you get b as 1. So the decomposition of this is this expression here with a replaced with negative 1 and b replaced with 1. So I'm going to write that down. The fraction a is negative 1 over x, and then plus another fraction, and it's going to be b, which was 1 over x minus 2. Okay. All right, this one, we look at this one here. The numerator's degree is 0, denominator degree is x cubed, so I can go ahead and factor. It's already factored, so now I just need to identify the types of factors. I have linear here, and here I have an irreducible quadratic because x squared plus 10 cannot be factored. So this is going to turn into some number over x plus, now because this is an irreducible quadratic, I need to put a linear expression on top, so I can put bx plus c. And now I multiply both sides by the common denominator. All right. And on the left side, I just get 10. On the right side, when I distribute here to here, the x's cancel, so I have the a. Still have x squared plus 10. And then when I do the second multiplication here to here, the x squared plus 10's cancel, so I still have the bx plus c, and I have x. So now 10 equals, I'm not going to do the shortcut method because anytime we have an irreducible quadratic, we're not going to be able to kill off the terms. So I'm just going to do the long way, which means expand all this out. So I just distribute a and then distribute x, collect my x squareds together. So a plus b, those are the coefficients for x squared. And then I have a cx, then I have a 10a. All right, so that takes care of all that. Now, if we notice on the left side, we don't have an x squared term, so there's really a 0 in front of it, and we don't have an x term, so there's really a 0 in front of that. So this a plus b has to match with 0. So we know that a plus b has to be 0. And then I know that the number in front of x has to match this one. So I know that c must be 0. And then I know that 10a has to match with this. So I know that 10a has to be 10. But that just means that a is 1. Divide both sides by 10. And then we already know that c is 0. And so we can use this equation, replacing a with 1, get 1 plus b is 0. So b must be -1. So we know what a, b, and c are. So now we're just going to rewrite this. We're going to replace, let me just go up here, replace the a with 1, so that'll be 1, and then b was -1, so -1x, and then plus c, but that's 0. So let's try this. I'm going to have 1 over x, and then plus, the other one's going to be -x over, oh, that's not right. That's potentially going to be a problem. So let me put the negative up here, -x over x squared plus 10. There we go. All right, next one. So we have x squared over x minus 2, that's linear. Squared means it's repeated, and then here's just a linear. All right, now I don't have to do long division. It's already factored. So I'm going to do a over the x minus 2. I'm going to do b over the x minus 2 squared. That's taking care of my repeated linear factor. And I have x plus 3, which is linear again, so I'm just going to put c over that. And now we'll clear fractions. So I multiply the left and right hand sides by x minus 2 squared times x plus 3. X minus 2 squared times x plus 3. All right, if we do that, we should get x squared on the left. On the right, let's see, the a will still be there. I lose one of the x minus 2's, but not both of them. I still have x plus 3. Then on the second one, I still have the b there, and the x minus 2 squareds cancel, so I still have x plus 3. And then on the last one, the c is still there, and I also have the x minus 2 squared. All right, I'm going to do long method, so I'm going to go ahead and distribute. So I'm going to go ahead and multiply those two together. It's going to be x squared plus x minus 6. Then I'll hit it with the a that's out front. So ax squared plus ax minus 6a. This one, I just distribute the b through, so bx plus 3b. And then this one, I have to square that. So if you square that, you get x squared minus 4x plus 4, and then pass a c through that. So cx squared minus 4cx plus 4c. Okay, x squared equals, all right, my x squareds, let's get these together. I've got x squared here, x squared here. So that's an a plus c x squared. And then my x's, I've got an x here, x here, x here. So I'm gonna put plus, now in parentheses, a plus b minus 4c, that's in front of x. Okay, now let's get my things that don't have x. So that's all those. So I'm going to have plus, let's see, -6a. I actually don't need this in parentheses, but I put it in parentheses, 3b and plus 4c. Okay, so now let's match coefficients. So I can see that the a plus c must be equal to the coefficient from x squared, which is 1. So a, leave a space there for the b, plus c must be 1. All right, the next one is that all of this has to be the coefficient from x. There is no x, so it's got to be a plus b minus 4c equals 0. And then the last one is that -6a plus 3b plus 4c must equal 0 again, because I don't have another number here by itself. Okay, all right, this can be a little tricky here. How should we do this? let me do something, because this is going to require elimination, which is a very long method. There's like, we don't know what A is, we don't know what B is, we don't know what C is. It's not simple, but let's go back up to this step right here. When we are right up here, do something. I did not do this in class, but let's say we were going to try the short way. And let's see if we can't figure out what, I think here. Let's try and get one of these. I think I can get B by letting X be 2. All right, so let's try that. Let's let X be 2. And if I do that, the left side, that X squared becomes 2 squared, that's 4 equals. Now we know that this one goes away. We know that one goes away. So that's just going to be B times 2 plus 3, because I replace X with 2. And so that's going to be 4 equals 5B. So B is 4/5. Okay, now if I know what B is, if B is 4/5, I can plug it in right here. I could also plug it in right here. Let's see, can we get another number? Let's see if we can't get another one. Okay, let's see, could we get C? I think we can get C if we let X be -3, because it will kill this and this. So let's let X be -3. So if we do that, the left side, when we square X, -3 squared is 9. That must equal these first two are gone. And now if I plug in -3 right here, we're going to get C -3 minus 2, that squared. So this is going to give us -5. We square it, we get 25. So that's going to be 25C. And if we divide both sides by 25, we get 9/25 is C. Okay, well, that's good, because if we know what C is, we can get A right here. So look, A plus C must be 1. So A plus C, we said, is 9/25, must be 1. So let's subtract 9/25 from both sides. Get a common denominator. So you have to multiply 1/1 by 25/25. And if you subtract there, you should get 16/25 for A. So we know what A is, we know what C is, we know what B is. All right, pretty bad, but that worked. Okay, so I think I'm gonna have to zoom out a little bit so I can see all this. Let me try and type this in. So I need A over X minus 2. So A was 16/25. But I need all of that. Let's see if this will do this. I need all of that over X minus 2 plus B, which is 4/5. So 4/5. But I need all of that. Come on. I need all of that over X minus 2 squared. And then plus C, which was 9, plus C, which was 9/25. But I need all of that. Come on. That's frustrating. There it is. Okay, that over X plus 3. All right, let's check that. Okay, it worked. Kind of messy, but you can see how this system of equations was not simple to solve. So I actually used the short method to grab a couple of values and then used it together with this. All right, next question. All right, so we have 5/x cubed minus 8. So we don't need long division, but we do need to factor. So you need to realize that x cubed minus 8 is a difference of cubes. So if we go to the difference of cubes formula, this will turn into x minus 2 times x squared plus 2x plus 4. So I'm using that difference of cubes formula. I'm not going to write it down. So here's where we are. And now we see that we've got a linear right here, and then the other one is an irreducible quadratic. So that means that this has to turn into some number over our linear plus some linear expression over our irreducible quadratic. And now we multiply both sides by the LCD. So I'm going to go a lot faster now. I know that when I multiply the left side by the LCD, I just get the 5. On the right, I'm going to get the a, the x minus 2 cancels, so I'm left with the x squared plus 2x plus 4. And then on the other one, bx plus c is still there, and then the quadratic part cancels, but I still have the x minus 2. Okay, I'm gonna try and go after this with the long way, so distribute the a through. Then on this one, I'm going to FOIL, so we get bx squared minus 2bx plus cx minus 2c. Okay, collecting together x squared, I've got a plus b. X squared, that takes care of those. X's, I have 2a. I have minus 2b plus c. Those are my x's. That's this one, and this one. And then the thing by itself is just 4a minus 2c. All right, so here we go. We've got the number in front of x squared has to be 0. So a plus b has to be 0. Okay, the next one, 2a minus 2b plus c. That must also be 0 because we don't have an x on the left side. And then 4a minus 2c has to be 5 because that's the number by itself. So here's my system. Okay, so what I can do here is I can solve, well, I can solve this for a, solve that for a, set them equal to one another. So again, this is where you could use a system. You might be able to get, I think if I go back to this point again right here and incorporate just a quick short method, let x be 2. If I do that, I'm gonna be able to kill this off. So if x is 2, the left-hand side is 5, and the right-hand side is a, and then just plug 2 in here. So 2 squared is 4, 2 times 2 is 4, so you get 4 plus 4 plus 4, that's 12. So a is 5 over 12. So we know what a is. So if I come to this one and replace a with 5 over 12 plus b has to be 0, then that tells you that b has to be negative 5 over 12. And now I know what a and b are, so I should be able to do this equation. I replace, let's see, a with 5 over 12, and then I replace b with negative 5 over 12, and then plus c equals 0. So when I do this, I get 10 over 12. That's just multiplying straight across. This is really like a 2 over 1. And then minus these two multiply straight across, give me another 10 because negative and negative is positive. Those have the same denominator, so I can add them together. 20 over 12 plus c equals 0, and just move that over to the other side. C is equal to negative 20 over 12, and that fraction reduces to be, what goes in there? 4 goes into there, both of those, negative 5/3. So we know a, b, and c. So a is going to be here, so let me try and write this, try and do this a different way. Fraction up here is going to be, it was 5 over 12. On the bottom is x minus 2. So that worked better. And then plus, okay, we have a fraction. And on the top, we have b, which is negative 5 over 12. So I'm going to put that like that. Negative 5 over 12 x plus c. C is minus 5/3. All over the irreducible quadratic, x squared plus 2x plus 4. All right. Okay. Cranking them out. Okay, so now new page here. So we have x plus 1 over x squared. That's a linear that's repeated, and then x squared plus 4 is an irreducible quadratic. Don't need long division, don't need to factor. So I'm going to have a over x, b over x squared, so I'm letting the power on that come up. Then a linear expression over my irreducible quadratic. Okay, I clear fractions. When I clear fractions, the left side is just x plus 1. The right side is a. I still have an x. I also have x squared plus 4. Then I have b. The x squareds cancel, so I still have just the x squared plus 4 in the b. And then the cx plus d is still here. The x squared plus 4 cancels, and I should have x squared out there still. So I'm not showing these steps anymore, just clearing the fractions because I'm hoping you get the idea. And I'm trying to work through these quickly without leaving out too much. Okay, now distribute. So ax cubed plus 4ax. And let's see here. Distribute through. So bx squared plus 4b. And then finally, cx cubed plus dx squared. So that was a pretty simple expanding there, or simplifying that out, or multiplying that out, I should say. So my x cubes are here. So I have a plus c x cubed plus, see, my x squareds are here and here. So plus b plus d x squared plus, let's see, x's, I only have one of them, 4a x, and then just 4b. All right, this should be pretty easy to match up. I don't have any x cubes on the left, so a plus c has to be 0. With a little more room there for the d, okay. A plus c is 0. Okay, next one says that b plus d has to be 0 also because there's no x squareds. 4a has to be equal to 1 to match the left side, the coefficient in front of x. And 4b has to also equal 1 to match the number by itself. So this is pretty straightforward. We can get that a is 1/4. We can also get that b is a 4th. And once we know what those are, it's easy to get the next two. So using this one, I know if a is a 4th, it's 1/4 plus c equals 0. So moving the 1/4 to the other side, you get negative 1/4. And then this one, if I know b is a 4th, 1/4 plus d equals 0 means that d is negative 1/4. So we should be ready to type this in. A, B, C, and D, we know them. So here we go. Fraction. Up top, we have another fraction, a. That's 1/4 over x. Okay, plus we have fraction, and then on top, b is a fraction. It's 1/4. And that's over x squared. I'm just moving my cursor to move around here. Okay, next one is a fraction, and then c is a fraction, so negative 1/4 in front of x, plus d, which is also a fraction, so minus 1/4 again, and that's all over x squared plus 4. All right. Okay, next one. All right, we do not need long division because the top is a quadratic. The bottom is really a 4th degree, but what we have here is x squared plus 9. That's a quadratic, that's irreducible, but then squared. So what I need to do here is put first a linear over the irreducible quadratic. Then I start building up the powers. Now another linear over the irreducible quadratic squared, and that's where I stop. I clear the fractions. When I do that, I'm going to be left with the ax plus b. One of the x squared plus 9s goes away when we clear, so we still have an x squared plus 9 there. And on the other one, when you multiply through, the cx plus d is still there and everything else cancels, so we can just leave it like that. And now I'm going to just FOIL this out. So let's see, ax cubed plus 9ax plus bx squared plus 9b. So that's just me multiplying these two together. And I still have the cx plus d out here. Okay, gather my like terms together. And let's see, x cubed, so I only have one, x cubed, okay. X squared, I only have one, bx squared. Okay, x's, I do have a few. Let's see, I have 9ax, so 9a. And then I have a cx, so plus c, that's my x's. And then the number by itself, or the things without x, is 9b plus d. Now we match things up. We don't have an x cubed over here, so a must be 0. B, we don't, oh, we do have an x squared there. So b has to be the number in front, which is 1. Okay, x's, we have a 2 over here, so I know that 9a plus c has to be 2. And then here, we know that 9b plus d has to match with the number over on the other side, -8. All right, we know what a is. A is 0, nice. The second one tells us b is 1. And if we know what a is, if a is 0, this third equation tells us that c is 2. I don't know why I wrote 0, 2. And if I know that b is 1, then if I replace, using the last equation, if I replace that b with 1, we get 9 plus d equals -8. And subtract 9 on both sides, d is -17. So we know what a, b, c, and d are. This one should be a little easier to type in. So a is 0. So I'm not going to put that here, just b. B is 1, so I'm going to put 1 over x squared plus 9. And then plus, let's see, c is 2. So let me put a fraction here. C is 2x minus 17, because d is minus 17, and then x squared plus 9. Oops, I forgot to put it in parentheses so I can square it. Check that. Let's see. Okay, I'm still recording. I got a little paranoid there that I wasn't recording. Okay, let's see. Next one. Give me just a second. Pause this recording real quick. Okay, so for this one, we do not need long division. Again, I don't believe any of these problems in the homework require long division. Let's see, minus 6x. Okay, but we do need to factor. So 14x plus 18. Let's go ahead and factor this over here. X cubed minus x squared minus 6x. We can pull an x out, greatest common factor. And then the remaining quadratic can factor to be x minus 3. It's x plus 2. And so we're going to just get 3 distinct linear factors here. So this one should be straightforward. We should be able to use the shortcut method here. We should just be able to put a over x, put b over the x minus 3, and then c over x plus 2. And now let's clear fractions. Let me do something real quick. Let's clear fractions out here. So we should be left with 14x plus 18 equals, all right, we'll be left with the a here. We'll be left with the x cancel, so we'll start with x minus 3, still have x plus 2. Next one, the b stays, and now we still have the x and the x plus 2. Now last one, the c stays, and we should still have the x and then the x minus 3. All right, short way. So let's get a. So let's let x be 0. let x be 0, and that should kill off the b and the c. So if we do that, x is 0. Be careful, you have to plug it in everywhere. The 14 times 0 becomes 0, and you have 18 on the left. Then a, and then you get 0 take away 3, which is -3, and 0 plus 2, which is 2. Then all the others are gone. So you get 18 equals -6a, which means that a is -3, dividing both sides by -6. Now let's get b. So if we get b, we have to let x be 3. That will kill off this one and this one. So if x is 3, we plug 3 in there, that's 30, 42 plus 18, 60. So we get 60 on the left equals, okay, the first one's gone, second one is not, we have b, we have 3, and then 3 plus 2, and then the second, the c part's gone because we let x be 3. So this should just be 60 equals, see 5, this is 5 times 3 is 15, so 15b, divide both sides by 15, b is 4. All right, last one, if we're going to get this one, we have to let x be -2 to kill these two off. So let x be -2. And if we do that, the left side, that's -28 plus 18 is -10. And then these two are gone. So we have c, we have -2, and then we have -2 minus 3. So this gives us -5 times -2, that's 10. So 10c equals -10, so c is -1. All right, so we know what A, B, and C are. So here we go, we're ready. A is -3 over x, plus the next fraction is b, which is 4 over x minus 3. And plus the last one, which is c is -1. Oh, I did the wrong thing here. So c is -1 over x plus 2. Okay. Next one, I think I may not do this one. This one's going to be the short method. 9, I'm just going to factor the bottom. Let's see, 3x, x. Oh, you know what? I will work through this one. We should have -4 and -1 on the factoring there. That gives you 3x squared minus 12x minus x, that's minus 13x, and then plus 4. So that's it. I'm going to put number on top of each of the linear factors because I have 2 of them. Clear the fractions. I get a, and let's see, you should get the x minus 4 here, and then b, and then I should get the 3x minus 1. Okay, so the thing that's tricky about this one, I'm going to use a short way, is how to kill this off. So if you're unsure of how to kill this off, just set it equal to 0. And then solve. So 3x equals 1, x is a third. So if I let x be a third, I should be able to kill off that second one. So we'll have 9 equals a, and then we have 1/3 minus 4, and then we know that when we plug in a third here, it's going to go away. So we do need to figure out what 1 minus 4 is, or sorry, 1/3 minus 4, so I'm going to write 4 over 1, get a common denominator. So multiply top and bottom by 3. So this is a -11/3. So this becomes 9 equals -11/3 a. And then I'll multiply both sides by -3 over 11 to clear it out. So it goes 11's cancel, -3, it's all gone. So you just have the a here. And then here you're going to get -27 over 11. That's what a is. Now, to get the b, it's a little easier because we can just let x be 4. If we let x be 4, we're just going to get 9 equals, the first one's gone. Here we're going to get b, and it's going to be 3 times 4 minus 1. So that's 12, take away 1, it's 11. So we get 9 equals 11b. Divide through by 11, and you get 9 over 11. So let's try this. So first, a is -11/3. No, a is -27 over 11, but that's on top of 3x minus 1. Oops. over 3x minus 1. And then b was, another fraction here, b was 9 over 11. And that's over x minus 4. Okay. All right, so for this one, 5x plus 2 over, let's see, the bottom I'm going to factor because it's not factored yet. So I pull out an x squared out of both of these and I get this. And then I notice that this is a difference of squares, so it factors even more. So x squared, and then I have x plus 2, x minus 2. Yeah, I'm not going to work through this one. I'm just going to get the partial fraction set up. So you have a over x, because this is linear repeated, b over x squared. Okay, that takes care of that. And now each of these are going to just require a letter over them. Yeah, okay, and then I'll let you go ahead and go through the rest of that. I think we've done enough of these. Let me see what the next one looks like. Oh, okay, so yeah, finally we need a long division first. So in this one, I'll at least get through the long division part. Okay, power up here is bigger than this one, so we need to do long division. So I put in the division box, x cubed plus x squared, and then I'm missing an x here, so I'm going to put plus 0x, and then minus 3, and then on the outside I put the divisor. All right, now, what do you need to multiply x squared by to get x cubed? Well, you need an x. And now that x is going to multiply to each one of these. And I put those underneath here. So I have x cubed, that's what I get when I multiply here. Here times here is 2x squared. And then here times here is negative 3x. So see how that negative 3x is going to be right here under this 0x? If you forget that 0x, it's going to be a problem. Now we subtract, so minus, that becomes a plus. When we add down, these go away. X squared take away, 2x squared is going to give you negative x squared. And then here you add down, you get 3x. And then when you add this down, you just get minus 3. Okay, we can keep going now. Look, we need to turn x squared into negative x squared. So we're going to multiply by negative 1. So if we multiply by negative 1, we get negative x squared. Negative 1 here, we get negative 2x. Negative 1 here, we get positive 3. And now we change the signs. Don't forget, everything changes. This becomes a plus. This becomes a plus. This becomes a minus. So those cancel. Here we get 5x and then minus 6. So that's our remainder. Can't go any further because we have x squared out here. Can't turn it into 5x. Okay, so far what we can say is this is equal to x minus 1 plus 5x minus 6 over this denominator, but I'm going to factor that right now. Okay, and now what we'll do at this point is just look at this, and we're just going to look at, we've got distinct linear factors, so that turns into a over x plus 3, and then plus b over x minus 1. So what you're going to do is you're going to do this. You're going to, probably the short method would work here. Figure out what a and b is, and you'll get your answer for there. But don't forget, your final answer will be x minus 1 plus whatever you get for a over x plus 3 plus b, and then whatever you get, or whatever you get for b, and then over x minus 1. So you have to do this part, but then you have to remember that these two parts came from the long division, so that's part of your answer. I'll leave those to you. I think you can handle it. And if not, at least you'll have questions for me. All right, hope this helped.